Okay, kids, I hope you enjoyed your weekend. Let's have a quick class meeting, go over some curriculum, timetable for the curriculum, and then we'll get into some work, and you'll have some homework. Good. As you can see here, I've got our timetable. We've got 22 days from now till the end of school to go through Module 6, Eureka, on geometry. Yesterday, as a warm-up, we started some problems for finding x and y. Today, I want to reaffirm in your mind some basic geometry concepts. Let's start from the beginning. Adjacent angles. Adjacent angles are merely angles that are side by side. Therefore, this angle is beside this angle, and it adds up to a greater angle C. So this is an angle. Sorry for the writing. It's not so easy to hold. And here, so this is demonstrated here. Angle A, this area, plus angle B, this area, gives us angle C, this entire area. Okay? So adjacent angles just mean one small angle plus another small angle gives you the entire big angle. This angle segment plus this angle segment gives us this entire angle segment, which equals this whole space. So this angle A is adjacent to angle B, forming a greater angle C. Therefore, angle A plus angle B equals angle C. Next topic, we went over, you'll recall, vertical angles. Vertical angles are, as I showed you yesterday, angles directly across from each other are equal. So A is equal to B, and this angle is equal to this angle. Vertical angles. All right, we talked about this one time and time again. The major lesson from yesterday was angles on a line. Angles on a line add up to form a total of 180 degrees. So this angle A plus this angle B gives you 180 degrees. So angle A plus angle B, there should be little angle symbols here. Angle A plus angle B equals 180 degrees. And finally, angles at a point. Now this is actually a bit interesting because remember, we're on the imagination board. We're not looking at an actual object. We're looking at our perspective of an analysis. Now, in actuality, where this diagram you're witnessing exists in real life is when this is the axis and it's coming out of the board that way, okay? So it would be like almost touching you, from you to touching that, and then it keeps going off into space back that way, through the wall, now into the, dimension back there behind the wall. So almost like a ray gun. From you, zip, zap, zip, zip, zip back, and then all the way back. Now you might imagine then, what you're looking at then is a cross section of, let's say, a log. So let's say this is a log that goes all the way back there, right? So here's the top of the log. And here's a little man, dancing on the log. Okay? Now if you cut that log with a saw, here, you get this slice that you're looking at. This is the face of it. This is the face of the log if you cut it. So what it's saying then is, as you would imagine, the log all the way around is from here to here to here, and all of that equals, you guessed it, 360 degrees. So this section, this angle here, angle B, plus this section here, angle C, plus this section here, angle A, gives you 360. All right? Good. Great. You're also going to recall from class before we broke out that there were two definitions that we went over constantly, every day. There were complementary angles and supplementary angles. I'm sure we came up with a song that I don't remember. But the bottom line was complementary angles are when two angles add up to 90 degrees. That's why 90 degrees makes that shape there. Now supplementary angles are angles when they add up, they form 180 degrees. So here you have a 120 degree angle, a 60 degree angle, forming a 180 degree angle. Okay, and here you have, with a complementary angle, you have a 30 degree angle and a 60 degree angle and a 30 degree angle coming together to form a 90 degree angle. We also define this as perpendicular to this line. These lines are whenever you see a 90 degree symbol, that means this line has been bisected, remember, by this line perpendicularly. Perpendicular means 90 degrees. Perpendicular. Bisect. Perpendicularly, okay? This line here has been bisected by this line perpendicularly. That means at a 90 degree angle. The reason why I emphasize that over and over again is because, in construction, for example, you can't just cut through a line. You have to bisect it at a perfect 90 degree angle to make sure everything's level. If you remember, I mentioned to you back a while ago, I talked about level in relationship to gravity. That's another conversation. But this symbol is the universal symbol for level in construction, for example. Okay? So when you see that symbol, you know you're level. All right. So complementary, 90 degrees. Supplementary, 180 degrees. Let's do a problem. Okay. So we're on page S3 in your book. It says, the measure of two supplementary angles are in the ratio of 2 to 3. Find the measurements of the two angles. Guess what time it is? It's time for you to turn on that imagination. I need you to turn on your imagination because this is a little funny in the brain if you're not using your imagination. Got to use your imagination. Here we go. You ready? In this problem, we know the angles are supplementary. Therefore, the rule tells us that angle A plus angle B equals 180 degrees. Now, we're also told the ratio representing angle A to B is 2 to 3. That means every time you see one of these, for example, you're going to see, oh gosh, hang on. Sorry. Every time you see two A's, for example, you're going to see three B's. Okay? So, in terms of numbers, because everything isn't going to be clean as a constant A and a constant B, you could get a number that's 22.23767. But no matter what the number is, it has to look like this. So, therefore, you can think of A as 2x, because we don't know how many there are going to be actual. This number could be, A could be any number under the universe. But it's always going to fit this pattern, that there's two of them every time you see a B. So we'll call that 3x. Is that imagination working? Okay. You know what to do here. We've got 2x plus 3x. What do? Combine like terms. 2x plus 3x is 5x. Equals 180. What do we do now? We disconnect the 5 from the variable using the opposite. 5 is connected to x by 5x, right? Therefore, to unconnect it, we need to divide by 5 and divide by 5 here. What happens to this 5 and this 5? They cancel out. What are we left with? X. Very good. X equals 180 over 5. 180 over 5 is the same thing as 5 divided by, same thing as 180 divided by 5. Use your division. So x equals 36. Now, that means every time we see an x, okay, you're going to take that and multiply it times 2. And every time you see a b, you're going to take that x and multiply it times 3. So in this case, so in this case, 36 and 2, 72. In the case of A, and in the case of B, we'll take 36 times 3 is 108. So A equals 72 and B is 108. All right, good work.